Hi guys, in this video we're going to talk about measures of central tendency and dispersion of univariate data. Let's start by talking about the values that describes the center of a univariate data. The first one is the mean, and the mean is the sum of the data divided by the number of data. The median is the middle value or the mean or average of the middle two values when the data is arranged in numerical order. Now let's talk about the values that describes the spread of the univariate data or dispersion. The first one is the range, and the range is the difference between the largest value and the smallest value, or the maximum value minus the minimum value. The second value that describes the spread is also the standard deviation. And the standard deviation measures the amount of variation or dispersion from the average. And the standard deviation sometimes is given the notation sigma to indicate standard deviation. So the smaller the standard deviation, the closer the data to the mean and the less variation we have in the data. The greater the standard deviation, the further the data from the mean and the more variation we have in the data. Let's take a look at this example where we have 10 men and they have different heights, and these heights are in inches. We need to find the mean, the median, the range, and the standard deviation to the nearest hundred of that set of data. So the first thing I need to do is to organize these data points into a table. And this table, I'm going to call the frequency table, because in this table, I'm going to have the value, the frequency, which means the number of times this data point is repeated. And then in the middle here, I'm going to have tallies to count the number of times I see the data. So I see, in this data set, I see 67 once, and I see 68, 1, 2, 3, 4 times, 68, 1, 2, 3, 4, 4 times. I see 69, 1, 2, 3 times, 3 times. I see 70 once, and I see 71 once. And when I add the frequencies, I should end up with the same number of data points that I have at the top. I have 1 plus 4 plus 3 plus 1 plus 1 is 10, and I have 10 data points. That means I did not forget any data points. Now we're going to use the TI-84 calculator to find the values of the mean, median, to measure the center of this data, and the range and the standard deviation to measure the spread of this data. To hit the stats button so we can put the frequency table in the calculator. So I'm going to hit the stats button and then a 1 or enter to put the data in. I'm going to put in the first column, I'm going to put the data, which is 67, and then 68, and then 69, and then 70, and then 71, and in the second column, I'm going to put the frequencies. So I'm going to start with 1, 4, then 5, Actually, 3, not 5. Three, and then I'm going to put 1, and then 1. So now that I have the frequency table in the calculator, I'm going to hit the stats button and then go to calc. Since this is a one-variate stats, I'm going to hit 1 for one-variate stats or enter. And then the calculator is going to ask me for the list. My list is in L1, and I need to indicate in the calculator that my frequency is in L2. So that's why I'm going to hit the blue button second, 2 for L2 to indicate that I have a frequency column. And now I'm going to run the stats. And the first value that I see is the mean, which is 68.7. The standard deviation is 1.1. The median is going to be 68.5. The minimum value is 67, and the maximum value is 71. So the mean is the first value, which is 68.7. The standard deviation is 1.1. The minimum is 67, and the median is 68.5, and the maximum is 71. Now, the calculator is not going to give me the range, but the range is basically the difference between the maximum and the minimum. So 71 minus 67 is going to be equal to 4. So the range is 4. And as you can see, because we have a small value for the standard deviation, which is 1.1, and because we have a small value for the range, which is 4, that means we don't have a lot of variation in this data, and the data points are close to each other over the range. An outlier is a score that is way out of range in regard to other scores. Let's take a look at this example to find out what an outlier means and how it affects a set of data. So we have two identical data points, except for the first value, which is 65 on the left side, and the first value is 0 on the right side. So looking at the left set, we see that all of these data are close to each other. There is no value that you can describe as odd or way out of range. And if you look at the mean and the median for these data points, you'll see that the median is 84, the mean is 83.4, and that these two values are very close to each other. And when these two values are very close to each other like that, we know that we don't have an outlier. And that the mean is the best value to describe the center of this data. It's the best presentation of the center for a set of value. Now, for the set on the right, we have 0, and 0 is a value that you can describe as odd or way further away from all the other data points. And this value, which is 0, is called the outlier, and it affects the mean of the data set. So in this data set, we'll find out that the median stayed the same. It did not change, but the mean changed and it's 79 now. So that tells us that the best presentation for the center of this data set is going to be the median, because the median is not affected by the outlier, but the mean is. So the outlier is a value that is way out of range in regard to other values, and it affects the mean of the data point. When we don't have an outlier, the mean is the best presentation of the center, while the median is the best representation of the center when we have an outlier in the data set.